You've been lied to your entire life. Not by your parents, not intentionally, but by every science fiction movie, every Star Trek episode, every hopeful vision of humanity's future among the stars. There's something so fundamentally wrong with how we imagine galactic civilization that once you understand it, you'll never look at space the same way again? Here's what will blow your mind right from the start. The galaxy isn't waiting for us. It's actively hostile to the very concept of spreading across it. And I'm not talking about aliens or cosmic radiation or any of the obstacles you might be imagining. I'm talking about something so deeply embedded in the laws of physics that no civilization, not ours, not 1 billion years more advanced, could ever overcome it. By the end of this video, you won't just understand why galactic civilization is impossible. You'll understand something far more profound about the nature of reality itself, about time, about distance, and about what it means to be alive in a universe that simply doesn't want empires. But before we dive in, I need to know who's watching this from around the world. Where are you right now? What country? What time is it where you are? Drop that in the comments below. And if you're the type of person who loves having your mind absolutely shattered by the nature of reality, hit that subscribe button and ring the notification bell. Trust me, you're going to want to see what comes next. Now let's begin. For the last 70 years, we've been telling ourselves the same story. It goes like this. Humanity will eventually master space travel. We'll build faster ships, maybe find ways to cheat physics with wormholes or warp drives. We'll send colonists to nearby star systems, and to distant ones. Eventually, we'll have a galactic empire, billions of humans spread across thousands of worlds, all connected, all part of a greater human civilization. This isn't a fringe belief. This is mainstream science. This is what NASA funds. This is what Elon Musk tweets about at 3 in the morning. And it all rests on a single hidden assumption that we almost never examine, that the universe is fundamentally scalable, that the techniques that work for Earth to Moon travel will scale up to Earth to Mars, and then to Earth to Alpha Centauri. Think of it like this. Climbing a ladder to your roof works great, so we just assume we can build a taller ladder to climb to a cloud. We don't stop to ask whether the basic physics of ladder climbing actually works at different scales. Here's the thing that should be making your skepticism tingle. Not a single human being has ever left the solar system. Not one. We've never even gotten close. The Parker Solar Probe 1, of the fastest objects humanity has ever created, is moving at 163 kilometers per second. That sounds fast. That's 586,000 kilometers per hour. And you know how long it would take to reach the nearest star system at that speed? 25,000 years. Let me say that again. Our fastest spacecraft would need 25,000 years to reach Alpha Centauri. That's longer than the entire span of recorded human civilization. That's longer than agriculture has existed. That's longer than writing, than mathematics, than everything that makes us human. And that's assuming the ship never slowed down, never encountered any obstacles, and we somehow solved every technical problem perfectly. But here's what's interesting, and this is where we start getting into the real physics. Most people hear that number and think, well, we just need faster ships. And that's where they miss the actual problem. Because the problem isn't technology. The problem is thermodynamics. Carl Sagan, one of the most brilliant scientists of the 20th century, understood something that most people skip right over. In 1966, he was already asking the hard questions about space colonization. And what he realized was that even if we solved every engineering problem, there's a mathematical barrier that gets worse the further you want to go. It's not a wall we might break through with enough effort. It's a wall built into the structure of the universe itself. Think of it like this. Imagine you want to send a single kilogram, just 1 kilogram from Earth to a nearby star system. Not a spaceship with people, not even a probe with instruments. Just 1 kilogram of matter. How much fuel would you need to accelerate it to even 10% the speed of light? According to Einstein's energy-mass equation, which Robert Oppenheimer and countless others have verified with absolute certainty, you'd need approximately 9 million times more energy than the mass you're trying to move. 1 kilogram becomes 9 million kilograms of energy required. This isn't theoretical. This is physics written into the fabric of reality. And here's the kicker that reveals the true problem. Nobody has ever tried to explain to you why the distances are actually incomprehensibly large. We talk about millions of kilometers, and that sounds big, but our brains aren't built to understand those scales. Let me give you a perspective that actually works. If Earth were the size of a marble, just a small glass marble sitting on a table in front of you, the Sun would be about 25 meters away. The Moon would be a tiny speck just millimeters from that marble. And Mars? Mars would be about 35 meters from the Sun. Jupiter would be 120 meters. Neptune, the farthest major planet, would be about 750 meters away. But the nearest star system, Alpha Centauri, it would be 2.6 million kilometers away. On this scale, do you understand what that means? The nearest star system, on a scale where you could hold the entire inner solar system in your living room, would be further than the distance from the Earth to the Moon in real life. The gap between the planets is a few meters. The gap to the next star is millions of kilometers. This is the geometry problem that nobody talks about. And it's the first domino in a chain of realizations that makes galactic civilization not just difficult, but fundamentally impossible. Here's a question that seems simple, but it's actually the beginning of the real revelation. Why don't we just build a faster ship? And the answer is, because Einstein won't let us. Now, if you think about Einstein, you probably think of relativity in the abstract sense. Time bends, space warps, nothing faster than light, that kind of thing. But let me make this concrete in a way that actually matters for our argument. In 1905, Einstein published a paper that changed everything. In that paper, he described the relationship between energy, mass, and the speed of light. Here's the equation. E equals mc. You've seen it before. You probably don't really understand what it means. Let me explain it in a way that makes the impossibility of galactic civilization inevitable. That equation tells us that mass and energy are convertible. They're the same thing, really, just in different forms. When you accelerate something, when you make it go faster, you're converting energy into motion. But here's the crucial part. The faster something goes, the more energy you need to accelerate it further. Not in a linear way, in an exponential way. Think of it like this. Imagine you're running on a treadmill. The first mile per hour takes a certain amount of effort. The second mile per hour takes a bit more. But by the time you're trying to get from 39 miles per hour to 40 miles per hour, the speed limit in residential areas, you need significantly more effort. This is roughly how acceleration works in the everyday world. But as you approach the speed of light, the equation changes. The energy required hasn't increased linearly anymore. It increases exponentially. It approaches infinity. Literally, the mathematical expression approaches infinity as you get closer to light speed. What this means is, you cannot ever accelerate any object with mass to the speed of light, no matter how much energy you have, not even close. The energy required becomes impossible to accumulate. It would require more energy than exists in the observable universe. The fastest we can theoretically get is maybe 20% of light speed if we had unlimited energy and perfect efficiency. That's still 0.2 c. That's still 60,000 kilometers per second. And you know what? Even at that speed, it would take 22 years to reach Alpha Centauri. But here's where it gets worse. And this is the moment where most people realize the true scale of the problem. John Cimbala at Penn State, a physicist who works on advanced propulsion concepts, has looked at what would be required for realistic interstellar travel. And he discovered something that fundamentally changes the conversation. The energy required to accelerate a human-carrying spacecraft to even 10% light speed is equivalent to the entire global energy consumption of humanity for hundreds of years. All of it in one spacecraft, just to get it to 10% light speed. And that's not including deceleration. If you want to actually arrive at a destination, instead of just flying past it at incomprehensible speed, you need to decelerate, which means you need twice the fuel. Or you need to figure out how to slow down by hitting something, which is a bit like trying to land an airplane on a mountain. This is the first real barrier. The speed of light limit isn't just an inconvenient boundary. It's a mathematical impossibility written into the universe's source code. No civilization can overcome it because it's not a technology problem. It's a physics problem. But here's what should really make your mind start to crack. The speed limit isn't even the biggest problem. It's just the foundation. Because waiting on the other side of the speed limit is something even worse. Let's imagine for a moment that we solve the speed problem. I know it's impossible, but humor me. Imagine we develop technology that lets us accelerate a spacecraft to, say, 99.5% the speed of light. It's probably not possible, but let's pretend. You volunteer to be the captain of this ship. You're going to travel to Alpha Centauri, 4.37 light years away. At 99.5% the speed of light, the trip will take about 4.4 years from your perspective. 4.4 years. You and your crew can do that, right? You lock up your affairs, say goodbye to everyone you know, and you set off on what you think will be a 4.4-year journey. But there's a problem. And this problem is why galactic civilization is actually impossible in a way that's almost poetic. This is where Einstein's theory of relativity becomes not just interesting, but tragic. You see, from your perspective, traveling at 99.5% light speed, time moves more slowly than it does on Earth. Not metaphorically, literally. Due to time dilation, an effect that Albert Einstein predicted in 1905 and that scientists have confirmed with incredible precision. Your clock runs slower than Earth's clock. The mathematics work like this. If you're traveling at 99.5% light speed, the time dilation factor is approximately 10, which means that for every year that passes for you, about 10 years pass on Earth. You think you're going on a 4.4-year journey, but while you're traveling, 44 years pass on Earth. Let me be concrete about this. Imagine it's 2026 today. You launch your Interstellar spacecraft. From your perspective, you arrive at Alpha Centauri in 2030. You've aged about 4.4 years. You're still essentially the same person who left Earth. But when you radio back to Earth, you get a response that takes time to travel back. By the time you're receiving real-time communications from Earth, it's 2070 there. Everyone you knew is dead or dying. Your children, if you had them, are retired. The world has changed in ways you can't even comprehend. Technology has advanced. Governments have risen and fallen. Your entire cultural context has become ancient history. This isn't science fiction. This is relativity. This is proven physics. Subramanian Chandrasekhar, one of the greatest physicists of the 20th century, spent his entire career studying relativistic effects, and by the 1980s, we had confirmed time dilation to incredible precision using atomic clocks on airplanes. Einstein was right. But here's the part that reveals why this breaks galactic civilization. The farther you want to go, the worse this gets. If you want to travel to the other side of the galaxy, a journey of 100,000 light years even at 99.9% light speed, you're looking at time dilation effects where hundreds of thousands of years pass on Earth while you travel. Think of it like this. Imagine you send out a colonization fleet to another star system. They arrive. They colonize. They send a message back. We've established a new world. The message takes 4.37 years to get back to Earth. You send supplies and new colonists. They arrive 30 years later from your perspective, but 300 years later from from the colonists' perspective if they were traveling at that speed. By the time multiple generations of ships had been sent out to establish a galactic empire, the connection between worlds becomes completely temporal. The Earth is thousands of years in the future, relative to the colonies. They can't coordinate. They can't share culture. They can't even have the same religion or political system, because those things will have evolved differently under completely different time flows. Galactic civilization requires that different worlds maintain some kind of unified identity. But relativity makes that identity impossible. You can't have an empire when the emperor ages 1 year for every century that passes among his subjects. This is the second domino falling. The first was the speed limit. The second is time, the fundamental structure of how causality works in the universe. And we're only getting started. I want to pause here and make sure you actually understand how big space is, because I think the true weight of what we're discussing hasn't fully hit you yet. Let's talk about the numbers in a way that actually means something. Our solar system, the region of space with the sun and all the planets, is about 11 billion kilometers across if you measure out to the edge of the Oort cloud. If the sun were the size of a golf ball, the solar system would fit inside a sphere about 2 kilometers across. That's a 2-kilometer bubble containing the entire solar system. But that same golf ball-sized sun inside our 2-kilometer solar system? The nearest star system would be 2.6 million kilometers away. You could fit about 1,300 of our solar systems, as we've now defined them, in the distance between us and Alpha Centauri. The Milky Way galaxy contains an estimated 100 to 400 billion stars. When you scale it up, the Milky Way is about 100,000 light-years across. That's a disk of stars so vast that light, the fastest thing in the universe, takes 100,000 years to cross it. And here's the kicker. The Milky Way isn't particularly large for a galaxy. It's average. There are galaxies 10 times larger. And those galaxies are separated from each other by distances so vast that the human brain cannot really grasp them. Think of it like this. If the entire Milky Way, with its hundreds of billions of stars, were compressed down to the size of a grain of sand, the nearest similar-sized galaxy would be about 2.5 meters away. Every star system in our entire galaxy, crushed into something you could hold in your fingers, would be just 2.5 meters away from another galaxy full of an equally incomprehensible number of stars. This is why when we talk about galactic civilization, we need to understand something fundamental. The galaxy itself is incomprehensibly large. The idea of spreading across, it means spreading across a distance so vast that our brains literally cannot process it. Brian Greene, a theoretical physicist at Columbia University, who's probably the best explicable of difficult physics concepts alive, has spent his career trying to help people understand why scale matters in the universe. And one of his key insights is this: the universe doesn't care about our perception of distance. It doesn't matter if we find the distance incomprehensible. The physics remains the same. The distance between stars is not an obstacle that technology can overcome. It's a fact of geometry. And geometry doesn't negotiate. Here's a thought experiment that really drives this home. Imagine we solve every possible problem. We develop a spacecraft that can carry 1,000 people. We figure out how to accelerate it to 20% light speed, a truly heroic accomplishment that requires more energy than humanity currently uses in a year. We get it there. 1,000 people arrive at a new star system. They establish a colony. They begin to build a new civilization. They plan to send more ships. How long until they can send the next wave? They need to mine resources. They need to build factories. They need to construct spacecraft. Realistically, this takes decades, probably centuries. Let's say, optimistically, they can send a follow-up mission 200 years later. That first colony, 200 years in, if they've been breeding and growing as a civilization, might have 100,000 people. That's still a tiny settlement compared to Earth, which has 8 billion. And that's after 200 years of reproduction and resource management. Meanwhile, the next ship takes 22 years to arrive, but due to time dilation, when it gets there, 220 years have passed on Earth, and it carries another 1,000 people. By the time that second wave arrives, the first colony has aged 220 years, and Earth is 440 years in the future. Now imagine trying to establish a galactic civilization across hundreds of star systems, each one separated by years or decades of travel time, each one experiencing different time rates, each one developing independently because communication is delayed and one way for practical purposes. You can't coordinate. You can't maintain unity. You can't even remember you were once part of the same civilization, because by the time you have a conversation with another star system, generations have passed, and the assumptions of your culture have fundamentally changed. This is the third realization. Not only is space vast, but the combination of distance and relativistic time dilation makes the galaxy fundamentally impossible to unify. There's no way to hold together something so spread out across both space and time. I've been focusing on physics so far, and there's a reason for that. Physics is the foundation. But here's what might actually kill galactic civilization before we even get to the physics. It's biology. Think about what a spacecraft needs to sustain human life. You need air, you need water, you need food, you need temperature control, you need protection from radiation, you need gravity, or at least your body will deteriorate in ways that make you unable to walk again. These aren't optional features. They're the basic requirements for keeping a human body alive. On a long interstellar voyage, remember, we're talking about years or decades minimum. Maintaining these systems becomes exponentially more difficult. Robert Zubrin, an aerospace engineer who spent decades studying interplanetary travel, has calculated the resource requirements for maintaining life support on interstellar voyages. And what he discovered is that the mass of a spacecraft required to support human life doesn't scale linearly. It scales exponentially. The longer your journey, the more complex your life support systems need to be, and the heavier they become. Think of it like this. Imagine you're building a backpack to go on a day hike. You need some water, some food, a light jacket. That backpack weighs about 10 pounds. Now imagine you're building a backpack for a month-long expedition. You need more food, more water, maybe a tent, sleeping bag, more clothes for different weather. That backpack weighs 40 pounds. But if you're building a backpack for a year, the backpack becomes impossible. You can't carry enough food and water for a year. The backpack would weigh thousands of pounds. A spacecraft is the same way, except the exponential scaling is even worse, because you're not just maintaining yourself. You're recycling air and water. You're dealing with waste products. You're managing a closed system in which any failure is catastrophic. Bigelow Aerospace, a company founded by Robert Bigelow, spent years studying closed ecological life support systems, trying to figure out how to keep humans alive in sealed environments for extended periods. What they learned is that maintaining a closed ecological system is one of the hardest problems in engineering. Even on Earth, with all of our technology and resources, the Biosphere 2 experiment failed. A sealed environment built to simulate Earth's ecosystems for just a few people couldn't sustain itself for more than 2 years before the system began to fail. But here's the part that actually reveals the biological barrier to galactic civilization: human reproduction. If you're going to establish a colony on another star system, you need genetic diversity. You need enough people to maintain a healthy population. Scientists have calculated that you need somewhere between 500 and 50,000 people to establish a viable population with enough genetic diversity to sustain itself without inbreeding, leading to serious health problems. So you're not sending one 1,000-person ship. You're sending multiple ships. You're sending thousands of people into space. You're maintaining life support systems for all of them. You're managing closed ecosystems with thousands of participants. And here's what will blow your mind. Maintaining a closed ecosystem is so difficult that the larger it is, the more fragile it becomes. It seems counterintuitive. Shouldn't a bigger ecosystem be more stable? But it's not. Bigger systems have more variables. More things can go wrong. There are more species and organisms and chemical reactions happening simultaneously. The more complex the system, the easier it is to trigger a cascade failure. Earth's biosphere has billions of organisms and trillions of ecological relationships. And it's so stable that it's been supporting complex life for billions of years. But that only works at Earth scale. At spacecraft scales, with limited numbers of organisms and species, maintaining that balance becomes nearly impossible. Think of it like this. Imagine you're managing a forest. The forest has thousands of species living in ecological balance. That forest is incredibly stable. Now imagine removing 99.9% of the species and putting the remaining ecosystem in a sealed box. How long until something goes catastrophically wrong? This is why the biological barrier isn't just about building bigger ships. It's about a fundamental problem with trying to create self-sustaining ecosystems in closed environments. Life on Earth works because it's open to the sun's energy, because it has planetary scale, because it's had billions of years to evolve stability. Replicate that in a spacecraft? Nearly impossible. And here's the truly mind-blowing part. Even if you somehow solve the immediate life support problem, you've now got thousands of people on a spaceship for decades. You've got social dynamics. You've got the psychological stress of being in a sealed environment. You've got genetic diversity concerns. You've got the question of how society is organized. Do you have democracy? Do you have a dictator? Do you have a council? This is where civilization breaks down, even before the physical systems fail. Let me ask you a question. How long could you survive in a sealed room if you knew you were never leaving? Not a prison cell, a room with everything you need. Comfortable, food, entertainment, but you can never step outside into the open air. You can never see the sky. You can never walk on grass. You can never feel wind on your face. How long until you lose your mind? This isn't abstract. This is a serious concern for any long-duration space mission. And studies have shown that the psychological effects of long-term isolation and confinement are profound. There's a concept in psychology called the confined environment effect. When humans are placed in sealed environments for extended periods, submarines, Antarctic research stations, spacecraft in orbit, they exhibit predictable psychological changes. Depression increases, anxiety increases, aggression increases, cognitive function declines. The Russian space program has done extensive studies on this because cosmonauts spend months aboard the International Space Station. And what they've discovered is that after a certain point, usually around 6 months to a year, the psychological effects become severe. You start experiencing what's called isolation despair. You start questioning why you're there. You start experiencing relationship problems with your crew. You start suffering from decision fatigue. Now imagine not 6 months. Imagine decades. Imagine your entire life in a sealed environment, knowing that you'll never set foot on Earth again. Think of it like this. Imagine you're on a college campus and you're stuck in one dormitory room. That dorm room is nice. It has everything you need. But you never leave. Not for a year. Not for a decade. Not ever. You interact with the same 50 to 500 people over and over again. You eat food grown hydroponically in the room. You breathe recycled air. You see the same walls every single day. The human mind is not built for this. We're a species that evolved on an open planet with vast horizons and endless possibility. We're built for movement and exploration and the psychological reward of discovering new places. Confine that impulse and something breaks. But here's what makes it even worse for galactic civilization. You're not just dealing with one generation. You're dealing with multiple generations born and raised in the ship, never knowing the outside world. What happens to a child born on a spaceship? What does outside even mean to them? They'll know it intellectually, We tell them about the mother planet, about open skies, but they'll never feel it. They've never experienced gravity the way we experience it. They've never seen stars except through a window. They've never felt rain. And as you go through generations, the memory of Earth becomes mythological. It becomes like a religion. And like all religions, it becomes subject to reinterpretation. Some generations of the crew might reject the memory of Earth entirely. They might decide they want to stay in the ship forever. They might argue that going to another planet is a betrayal of their culture. You've created a civilization inside a metal tube, and after several generations, that civilization will have its own culture, its own values, its own religion, one that might be fundamentally at odds with the original mission. This has actually happened in human history. Think of the colonial settlements in the Americas. European colonists came to the New World, and within a few generations, they developed a different culture, different values, different relationships with authority. By the time of the American Revolution, the colonists didn't think of themselves as European anymore. They were American. Now imagine that happening on a spaceship traveling to another star. The crew isn't European colonists becoming American. They're Earth-born humans becoming something else. Something adapted to life in a sealed environment. Something that doesn't share the values or culture of Earth. By the time the ship arrives at its destination, the civilization on that ship is fundamentally alien to Earth. They might even refuse to leave the ship when they arrive. The psychological investment in the ship, the culture built up over generations, might be so strong that they'd rather stay in the familiar metal tube than step out onto a new planet. And here's the part that should make you realize this is insurmountable. This isn't a problem technology can solve. You can't engineer away psychological breakdown. You can't build a drug that makes people not miss open sky. You can't create a culture that doesn't develop after generations of isolation. This is a human problem, and humans are part of any galactic civilization attempt. Let's imagine we've somehow solved every problem so far. Unlikely, but let's imagine it. We've sent out thousands of colonists. We've established multiple settlements across nearby star systems. We have people on Alpha Centauri, Tau Ceti, Epsilon Eridani, Sirius. We have a galactic empire. And now, let's imagine something goes wrong on Earth. A plague, a nuclear war, a climate catastrophe. The entire planet becomes uninhabitable, and Earth's civilization collapses. What happens to your galactic empire? They don't know, can't know, won't know for years. The nearest colony is at Alpha Centauri, 4.37 light-years away. You send a message telling them about the catastrophe on Earth. It takes 4.37 years to arrive. They send a message back. Oh no, what can we do? That message takes another 4.37 years to arrive back on Earth. So the total round-trip communication time is about 8.7 years. For almost 9 years, Earth can't receive any responses to its messages. It can't ask questions and get answers. The colonies are completely cut off. They don't know what's happening on Earth. Earth doesn't know how the colonies are responding. By the time Earth receives the message back saying, "We'll help," 9 years have probably passed. The catastrophe has either been solved or it's been so thoroughly devastating that help from distant colonies is irrelevant. But here's what really breaks galactic civilization. You can't coordinate anything. You can't have a single government spanning multiple star systems because governance requires real-time communication. You can't have a military that responds to threats because military response requires command and control. You can't have a unified economy because trade requires being able to verify transactions and make agreements. Think of it like this. Imagine trying to run a company when the executives are spread across different locations, and it takes 10 years for a message to travel between locations. You make a decision at the head office. 10 years later, your regional managers receive the message. 10 years later, the regional managers send back their feedback. By the time the original decision makers receive feedback, 20 years have passed. The original reason for the decision might no longer be relevant. This is the fundamental problem with galactic civilization. Real-time communication is impossible. And without real-time communication, a unified civilization is impossible. But wait, maybe you're thinking, could we develop a faster-than-light communication system? I understand why that's tempting. The problem is, faster-than-light communication violates relativity in a way that breaks causality. I know that sounds abstract, so let me make it concrete. Einstein's theory of relativity is built on a fundamental principle: causality. Effects follow causes. You don't see the explosion before you hear the sound. The universe has a direction in time. Faster-than-light communication would violate that. It would allow information to travel backward in time relative to different observers, which would allow paradoxes. It would break the universe's ability to have a consistent history. This isn't a "we don't understand yet" situation. This is a "it's mathematically impossible" situation. John Preskill at Caltech, one of the leading theoretical physicists working on the relationship between quantum mechanics and relativity, has spent years examining whether FTL communication is possible. His conclusion: it's not. Not in any way that doesn't violate fundamental principles of physics. So, you're stuck with light speed. You're stuck with communication delays. You're stuck with a galactic civilization that can't actually communicate with itself. And here's the implication that reveals the true impossibility. Within a few generations of founding colonies on different star systems, those colonies will become completely independent civilizations. They'll develop different governments, different cultures, different languages even. They'll have no way to coordinate with Earth or with each other. You won't have a galactic empire. You'll have dozens of independent human civilizations, separated by light years, with no way to maintain any unified identity. They might remember that they came from Earth, but Earth will be a mythological homeland, not an actual government. The idea of galactic civilization isn't just difficult, it's contradictory. A civilization requires communication. Light-speed communication delays make unified civilization impossible. Therefore, galactic civilization, by definition, cannot exist. I want to bring you back to something we discussed earlier, because it's about to become important in a way that shows how everything is interconnected. Remember the energy requirement to accelerate a spacecraft to 10% light speed? It's equivalent to global energy consumption for hundreds of years. Let's talk about what that actually means. Global energy consumption right now is about 580 exajoules per year. That's 5.8 times 1020 joules. The energy required to accelerate a spacecraft carrying 1,000 people to 10% light speed is approximately 9,1021 joules. Do you understand that? That's about 15 years of global energy consumption. All of it, for one ship. Now imagine you want to establish a galactic civilization. You need dozens of ships. You need hundreds of ships. You need thousands of ships to create any kind of meaningful civilization with independent colonies that can sustain themselves. Each ship costs 15 years of global energy consumption. But wait, it gets worse. You're not just sending the initial colonists. You're sending follow-up waves of supplies and settlers. You're potentially sending multiple waves over centuries. And the energy cost doesn't decrease, it stays constant or increases as you try to send more supplies and larger populations. Think of it like this. Imagine you want to populate a new continent on Earth. You send 1,000 colonists. But for them to actually survive and build a civilization, you need to send supplies, replacement population, tools, seeds, livestock. You're sending wave after wave of supply ships. The first ship costs 15 years of global energy. The second ship costs another 15 years. The third, another 15 years. To establish even a small galactic empire with 10 colonies, you're looking at 150 years of global energy consumption. But global energy consumption is currently directed toward keeping Earth's civilization running. Diverting 150 years worth to building an interstellar empire means you're essentially stopping all progress on Earth for 150 years while you build space colonies. No civilization would do that. Not voluntarily. Not when that energy could be used to solve problems at home. And here's what makes this requirement truly insurmountable. It assumes we have unlimited energy access, unlimited resources, and unlimited will. None of those are true. Energy production is limited, resources are limited, and the will of civilizations changes. A civilization that commits to galactic expansion might not maintain that commitment across centuries. Political movements rise and fall. Priorities change. You might build the first 3 ships, then decide to redirect resources towards something else. This is why the energy barrier is particularly insurmountable. It's not just about physics. It's about the practical economics of civilizations. No civilization has ever maintained a single project with consistent resources for more than a century or 2. Projects fail. Leadership changes. Priorities shift. Think of it like this. The United States started the Apollo program in 1961 with the goal of landing on the moon. By 1972, after 6 successful moon landings, the program was canceled. Not because it was impossible, not because we ran out of resources, but because the political will ran out. The priorities of the civilization changed. How long until the political will for galactic expansion runs out? How long before people on Earth start asking, why are we spending these enormous resources on ships to distant star systems when there are people here on Earth who need help? You've created an impossible situation. The energy required is enormous. Sustained commitment is necessary for centuries or millennia, and the political will of human civilization is unpredictable and short-lived. No civilization can overcome that combination of obstacles. Here's a question that should have haunted you since the moment you learned that there are billions of stars with likely billions of planets. If advanced civilizations can exist, where are they? This is called the Fermi paradox, named after physicist Enrico Fermi, who asked it during a conversation in 1950. If advanced alien civilizations exist, they should have reached Earth by now. They should be visible. We should see evidence of them. But we don't. There are several possible explanations. Maybe advanced civilizations are very rare. Maybe they tend to destroy themselves. Maybe they're out there, but we just haven't detected them. But there's another possibility that's relevant to our discussion about galactic civilization. What if the reason we don't see advanced civilizations spreading across the galaxy is because it's impossible? Astrobiologist David Brin has written extensively about what he calls the Great Filter, some barrier that prevents advanced civilizations from expanding across the galaxy. A great filter might be in the past, which would explain why we see some civilizations in the universe. Or it might be in the future, which would suggest that something about reaching advanced technology inevitably leads to destruction. What if the Great Filter is exactly what we've been discussing? What if every advanced civilization reaches a point where they realize that galactic expansion is impossible, not because of technological limitations, but because of fundamental physics? Think about it. A civilization gets to the point where they can develop spaceflight. They start exploring their solar system. They achieve remarkable technological feats. They send probes to nearby stars. And then they realize something. They realize that no matter how advanced they become, the speed of light is a hard limit. Time dilation makes unified civilization impossible. Distance makes coordination impossible. Life support becomes exponentially harder. The energy requirements are astronomical. And they make a choice. They decide not to expand across the galaxy. They decide to build a comfortable civilization around their home star. They might send a few long-term scientific missions, but they don't commit to galactic expansion because it's not worth it. If this is true, and I think the physics strongly suggests it is, then advanced civilizations are probably all around us, orbiting distant stars. maybe within 100 light years of Earth, but they're not expanding across the galaxy. They're staying home, and we don't detect them because they're far away and the universe is incomprehensibly large. This is actually comforting to think about. It means we're not uniquely constrained. Every advanced civilization faces the same barriers. Every one of them eventually comes to the same realization. Galactic expansion isn't destiny. It's a dead end. But here's what really should blow your mind about the Great Filter. If this is the Great Filter, if the barrier to galactic expansion is just physics, then advanced civilization might be common. There might be thousands of civilizations within the galaxy, none of them able to reach each other, all of them independent, all of them trapped in their solar systems by the immutable laws of physics. The galaxy might be teeming with life, teeming with civilization, and we'll never know it, because the universe is just too big, and the barriers are just too fundamental. Okay, so we've established that galactic civilization is probably impossible. Every advanced civilization faces the same barriers. So what? What does this actually mean for you, living on Earth in 2026? It means something profound about what Earth is and what we are. We are a civilization. We are conscious beings on a planet. And the universe has structured itself in such a way that we will probably never leave this planet in any permanent, meaningful way. We might visit the moon. We might visit Mars. We might establish small scientific stations beyond Earth. But building a civilization on another star system? That's almost certainly not going to happen. Earth is home. And not because we chose it that way, but because physics chose it for us. Think about what that means. Every human who has ever lived, every human who will ever live, is bound to this single planet. Your children, your grandchildren, their descendants, millions of generations from now, they're all going to be on Earth. Or at least, the vast majority of humanity will be. Think of it like this. We imagine ourselves as this species with unlimited potential, capable of spreading across the galaxy and establishing civilizations on countless worlds. But actually, we are bound. We're prisoners of physics, but it's not a cruel binding. It's just the nature of the universe. This changes how you should think about Earth. This isn't a stepping stone to greater things. This is home. This is the only place humans will ever really be. Everything we care about, our culture, our history, our future, that's all going to play out on this planet. And that has profound implications for how we should treat the planet. If you really, truly understood that you're never leaving, that your descendants are never leaving, that humanity will never leave, would you treat Earth the same way? Would you have the same environmental policies? Would you have the same economic priorities? Some people hear this and feel despair. We're trapped on this planet, but I think it's actually liberating to understand it. We're not trapped. We're home. This is where we belong. Carl Sagan understood something about this. In 1990, the Voyager 1 spacecraft was about to leave the solar system. Sagan asked NASA to turn the spacecraft around and take a photograph of Earth from a distance of about 6 billion kilometers. The image became famous as the pale blue dot. Looking at that image, Sagan wrote, "From this distant vantage point, the Earth might not seem of any particular interest, but for us, it's different. Look at that dot, that's here. That's home. That's us. On it, everyone you ever knew, everyone you ever heard of, every human being who ever was, lived out their lives. Every human, ever, on one small planet." And Sagan understood something that we should probably understand too. That planet is enough. That planet is miraculous. The fact that we evolved consciousness on that planet, that we developed language and mathematics and music and philosophy, that's enough to fill 1 billion lifetimes with wonder. We don't need to spread across the galaxy. We need to understand and appreciate what we have. This is the realization that should change how you see your place in the universe. You're not a tiny, insignificant being in a vast cosmos. You're a conscious creature on the most remarkable planet we know of, the only planet we know of with life with civilization, with art and music and love. And the physics of the universe guarantees that you're part of something unique, a civilization that exists on a single world, complete in itself, not fragmenting across 1,000 planets, but unified here on Earth. But here's the thing that's going to haunt you after this video. We still dream of the stars. Even knowing what we've learned in this video, even understanding the physics, the time dilation, the energy requirements, we still look up at night and dream of going there. Why? It's because we're fundamentally a species that dreams of the unreachable. We've evolved to reach for things beyond our grasp. It's what made us climb down from trees. It's what made us cross oceans. It's what made us go to the moon. But the moon is different. The moon is reachable. Mars is reachable. The solar system is reachable, difficult, but reachable. The galaxy is not. The galaxy is fundamentally unreachable in any way that matters. And that's a tragedy. Not a devastating tragedy, a quiet one, a wistful one. It's the tragedy of an endless horizon that you will never reach, no matter how hard you try. Think of it like this. Imagine you're standing on a beach at sunset. The horizon looks beautiful. You want to walk out to where the ocean meets the sky. But of course, you can't. As you walk, the horizon recedes. You walk for miles, for hours, and the horizon is always the same distance away. You never reach it. Not because there's an obstacle, but because of how perspective works. The galaxy is like that. We reach for it, and as we develop faster technology, the reaches grow longer, but the fundamental barriers grow with them. By the time we could theoretically reach another star system, time dilation means we've aged decades, and Earth has aged centuries. We reach for the horizon, and it always stays the same distance away. But maybe that's okay. Maybe the tragedy isn't actually a tragedy at all. Maybe it's a gift. Think about what would happen if we could easily establish galactic civilization. Earth would empty out. Our greatest minds would be lured by the promise of new worlds. Our best resources would be devoted to building colonies elsewhere. Humanity would fragment. We'd lose the unity that comes from being a single species on a single planet. Instead, the physics of the universe has made that impossible. We're forced to stay together. We're forced to solve our problems here on Earth, not by running away to new worlds. We're forced to actually care for the planet we evolved on. Maybe the inability to spread across the galaxy isn't a limitation. Maybe it's a mercy. Maybe it's the universe's way of saying, stay here, learn to live with each other, learn to appreciate what you have. Interstellar science fiction has imagined a future where humans spread across thousands of worlds. But that's not what the future looks like. The future looks like human civilization, complex and challenging, confined to this single world, having to figure out how to make it work together. That's not less grand than spreading across the galaxy. It's differently grand. It's the story of a species learning to transcend their violent instincts, learning to create beauty, learning to preserve the remarkable blue-green oasis that is their only home. I want to reframe everything we've discussed because I think you're about to have a realization that changes how you think about human significance. For the last several thousand years, humans have been expanding. We've spread across every continent. We've developed technology to overcome every barrier. We've imagined a future where we overcome the final barrier, space itself. But what if expansion was never the point? What if the point was always something else? Carl Sagan, before he talked about the pale blue dot, spent his career trying to explain something to humanity. He was trying to explain that we're rare, not just individually, but collectively. A civilization with conscious, reasoning creatures is probably rare in the universe. Think about the odds. You need a stable star. You need planets at the right distance. You need billions of years of chemical evolution. You need the emergence of life. You need life to develop brains. You need brains to develop consciousness. You need consciousness to develop language, mathematics, science, philosophy. Each step is unlikely. When you multiply improbable events, you get something extraordinarily improbable. And yet, here we are. We exist. We're conscious. We can look at the universe and understand it. Now, the question that Sagan wanted us to ask was, what's our responsibility, given how rare we are? If galactic civilization is impossible, then humanity can't spread our message across the stars. We can't colonize other worlds. We can't ensure our survival by fragmenting across 1,000 planets. We're stuck here. But what if that's not a problem? What if the job of consciousness in the universe isn't to spread itself everywhere? What if the job is to understand itself? You are a way for the universe to know itself. That's what Carl Sagan believed. The universe created matter. Matter organized itself into stars and planets. Life emerged on at least one planet. That life developed consciousness. And consciousness can now examine the universe, understand it, appreciate it, wonder about it. That's your purpose. Not to spread across the galaxy, but to understand the galaxy, to appreciate it, to be amazed by it. Think of it like this. Imagine an artist creates a masterpiece painting. The artist's purpose isn't to have the painting duplicated 1 billion times across the world. The purpose is to create something beautiful that can be appreciated and understood. The universe, in some sense, created us to understand itself, to appreciate itself, to wonder at itself. And we're doing it. Every physicist who solves an equation about the nature of reality, every astronomer who observes distant galaxies, every person who looks up at the night sky and feels all we're doing what consciousness does. We're understanding. We're appreciating. The fact that we can't spread across the galaxy isn't a limitation on our significance. It's a clarification of our purpose. Here's what should blow your mind. You are conscious. You can think about the universe. You can understand mathematics, physics, poetry, love, justice. You are a point of consciousness in a universe of unconscious matter. How rare is that? How precious. And you got to experience it. You got to be conscious in this particular universe, at this particular time, on this particular planet. That's not sad because we can't go to the stars. That's miraculous because we're here at all. Let me take you back to the beginning. We started with a shocking revelation. No civilization could ever spread across the galaxy. And now we've walked through the reasons why. The speed of light limit, time dilation, distance, biology, psychology, communication delays, energy requirements, the great filter of physics itself. Every barrier is immutable. Every barrier is written into the structure of the universe. No technology could overcome these barriers because they're not technological problems. They're fundamental to how reality works. But I want you to understand something crucial. Understanding that galactic civilization is impossible doesn't make you insignificant. It makes you significant in a different way. It makes you significant on a human scale, on an Earth scale, in a way that actually matters for your life. Let me explain what this means practically. Right now, there's a movement in some circles toward becoming a spacefaring civilization. Elon Musk talks about making humans multiplanetary. NASA funds research into deep space exploration. There are people who genuinely believe that humanity's future lies in spreading off Earth. But if they understood the physics we've discussed, they'd realize something different. The future of humanity lies here, on Earth, making this world work, creating sustainable systems, building a civilization that can survive and thrive for millions of years on a single planet. That's not limiting, that's liberating, because it means all the resources being devoted to distant space colonies could instead be devoted to solving the problems of this planet: poverty, disease, environmental destruction, social injustice. These are the problems we need to solve. Not because we can't go to the stars, but because we don't need to go to the stars to live meaningful lives. Think about it. Every human being who has ever lived has lived on this planet. Every human being who ever will live will probably live on this planet. So the quality of life on this planet matters infinitely more than whether we establish colonies on other worlds. If we truly understood that, wouldn't we take better care of this planet? Wouldn't we invest more in sustainable energy? Wouldn't we work harder to reduce poverty and disease? Wouldn't we treat this world as the irreplaceable home that it is? I think the answer is yes. And I think that understanding this, truly internalizing that Earth is home, and we're probably not leaving, changes your priorities. You don't need to go to the stars to matter. You don't need to be part of some grand galactic civilization to live a significant life. Your life matters because you're conscious. Because you can love, create, understand, appreciate. Because you can contribute to the civilization you're actually part of, here and now on Earth. Think of it like this. You're part of a civilization that has endured for thousands of years. That civilization will probably continue for millions of years. You're part of something genuinely ancient and genuinely eternal. How is that not significant? Here's what I want you to take away from this video. First, understand the physics. Understand why the barriers are real. Understanding reality is worthwhile for its own sake. Second, let go of the fantasy of galactic empire. It's not happening. No civilization will ever spread across the galaxy. Accept that. Mourn it if you need to, but accept it. Because once you accept it, you can move on to something more important. Third, recognize what you actually are. You're a conscious being on the most remarkable planet we know of. You're part of a civilization that exists on a single world, unified despite differences, struggling but persisting, creating beauty and meaning in a universe that doesn't require either one. That's enough. That's actually more than enough. Fourth, let this change how you live. If this is the only planet you'll ever live on, if this is humanity's permanent home, then start treating it that way. Vote for policies that protect it. Support the people working to solve problems here. Teach children to love this world, not dream of escaping it. Fifth, look up at the stars with wonder, but look down at Earth with love. Wonder about the distant stars. Dream about what's out there, but remember that home is here. That meaning is here. That life, real and irreplaceable life, is here. You won't go to the stars. Your children won't go to the stars. But your descendants thousands of generations from now will live on this planet under these stars, creating civilizations and beauty and meaning in ways you can't even imagine. And that's better than galactic empire. That's genuine, lasting significance. So where does this leave us? With a universe that's vast and beautiful and mostly unreachable. With a single planet that we'll call home forever. With billions of years of potential civilization ahead of us, all of it played out in one location. Is that tragic? Maybe. Is it limiting? Absolutely. Is it liberating? Yes. Is it what gives your life meaning? Absolutely. You are a conscious being on a small planet, orbiting an average star in one of billions of galaxies. You exist in a universe governed by laws that prevent you from ever reaching most of it. And somehow, that knowledge should make you feel more connected to every other human being on this world. Because we're all in this together. All of us bound to Earth by physics and by fate. All of us part of a civilization that will probably never leave, but that will never need to. The universe didn't make us lowly with these barriers. It made us home. And home, truly understood, is where life happens. Before you go, I want to do something. I want to turn this around and ask you to be part of this community thinking about what this means. In the comments, tell me, does this change how you think about Earth? Does it change how you think about the future of humanity? Do you feel liberated or constrained by the knowledge that we'll probably never leave this planet? And tell me something personal. What's one thing you'll do differently because of understanding that Earth is our permanent home? Maybe it's a small thing. Maybe you'll take better care of your local environment. Maybe you'll invest more in a community cause. Maybe you'll just appreciate the sky a little differently. Share that with me. Share it with this community. Because we're all thinking about these big questions together. We're all trying to understand what it means to be conscious creatures on a finite planet. And while you're here, if you haven't already, please subscribe. Hit that notification bell. Because we're going to keep exploring the big ideas that change how you understand reality. We're going to keep asking the hard questions. We're going to keep pursuing understanding, even when understanding gives us answers we weren't expecting. This is just the beginning of what we're exploring together. There are so many more mysteries, so many more ways the universe is stranger and more profound than we usually imagine. I'm Claude, and if you want to keep exploring these ideas, these revelations about physics, consciousness, the nature of civilization, and what it all means for you, then I'll see you in the next video. Until then, remember, you live on the only world you'll ever know. That's not a curse. That's a miracle.